Hello, this is our code along about how to build an AI predicting Pokemon system. It's part of our AI in Schools week here at DigiLearn Scott. For this example today, what we're going to do is we're going to be using two tools, one called Machine Learning for Kids, and we're going to use Scratch. But Scratch will open from within Machine Learning for Kids, so you don't have to worry about going to Scratch on its own just now. So just Machine Learning for Kids, and there'll be a website we'll go to that's got some images we're going to use on there as well. So the two sites that we're going to use for this code along are here, machinelearningforkids.co.uk and tinyurl.com/Pokemon AI, and you can scan the QR codes to get there. I'll show you those websites in just a few minutes. So the purpose of the code along today is to try and train an AI system to recognize the type of Pokemon that a certain character might be. So I'm sure we all know this guy. This is Pikachu. But what I didn't realize is that Pikachu is an electric Pokemon. And all Pokemon do have their own types. So for example, Pikachu is electric, and this one is called Jigglypuff, and Jigglypuff is a fairy. Now, there are all sorts of different types of Pokemon. There are fire, water, fighting, bugs, steel, fairies, ghosts. You can see them on the screen. And we want to figure out a way we can train an AI system to recognize what type of Pokemon a picture might be based on the information that we give it. So, for example, if we look at this Pokemon here, we look at the Pokemon and we might think to ourselves, right, how could we figure out what type of Pokemon Squirtle was just by the information that's on the screen here? Could we use just the picture and figure out, are there different shapes or colors that tell us what type of Pokemon Squirtle might be? Or could we look at the numbers that's associated to Squirtle about their hit points and attack and their height and all that, their fighting style? Could we figure out what type of Pokemon Squirtle might be should we have just the numbers? Well, in this task, what we're going to do is do the image training one, and I'll give you a link so you can have a look at the number training one as well. So the issue that we have is that whether we use the numbers or whether we use the pictures, neither way is perfect, because what a machine learning model does, what AI does, is it tries to find patterns in data that you give it. So we don't tell it what patterns to look for. It has to try and learn the patterns themselves. And that's called machine learning. So the task we're going to do is we're going to create a machine learning model. We're going to give that machine learning model some images of Pokemon to tell the machine learning model what type of Pokemon they are. Then we're going to test it. Then we're going to test it in Scratch to see if it works in Scratch. Then we're going to figure out if there are any flaws or issues with our little program. So to categorize our Pokemon, it could take a long time. There are over 1,000 Pokemon, but we're going to just use a few. So the ones that we're going to be using during this session are pre-built. The model's been built. It's got some examples of fire Pokemon, water Pokemon, electric Pokemon, rock, steel, and fairy. And what we will do is we will add some information about the bug type Pokemon. And once we've done that, we're going to train our model, we're going to test it, we're going to bring it into Scratch and see if we can have a Pokemon predicting Scratch program. So the websites you'll need once again are machinelearningforkids.co.uk and the tinyurl.com/Pokemon AI, which is the page on digilearn.scott. I will stop sharing this screen and I will move on to the activity. Just share a new screen with you. Share. And I want to share this window. Okay, so we're going to go to the two websites. We've got Machine Learning for Kids, and we have our Pokemon images, which looks like this. Okay, we'll come to this page in just a second. But first of all, we're interested in machine learning for kids. Now, if you come to the website machinelearningforkids.co.uk, and it might have an option that says, can I try it for free? That's the one you want to press. That's what you want to press. And With that, it should take you to this page here, and you should be able to kind of create a new project. So in this, you go to new project, and what we're going to do is press copy template. It'll take a long time for us to put all the pictures in, so we're going to use a template that's been pre-built. So copy template, scroll down and find Pokemon images and press import. So it's the one with the magnifying glass. Store on your computer. And here we have a pre-built model. When we click on this, we will see we've got three options: train, learn and test, and make. The first thing we want to do is to train our machine learning model to start to recognize pictures. So I'm going to press train. And in here, you will see that the model has been pre-built with some training material. So we have the fairy Pokemon here, and you can see there are 14. There are 14 fairy Pokemon here. There are 27 rock Pokemon. There are 19 steel ones. And you can see down here, we've got 26 water ones, 29 fire ones, and 18 electric ones. So they've all been pre-built. We take a long time to do that ourselves. What we'll do is we will add the bugs. Okay, so in order to do that, I'm going to press add new label, call it bug, press add. And you'll see at the bottom of this, you've got this empty box now, this empty container we can put our pictures in. Now, to make life a little bit easier, what we can do is you can just drag and drop the images from the website on DigiLearn Scott that I've shared, this one here. So to do this, it might be best if you can have two windows open. So I'm going to go to my Pokemon images, and I'm going to ask it to open in a new window. So open in new window. Move tab to new window. There we go. So I'm going to just make this smaller so I can see it here. Stick my images across here. I'm going to make my other window smaller. So what I've got now is I've got two windows. I have my Pokemon pictures on the right here, and I've got my machine learning for kids site on the left. Now you can do this on iPad as well, and you can use the split view to do that, and we'll show you, create a little video to show you how to do the split view. But the easiest thing at this point to do is just to scroll down to the bug box. I'm just going to just drag the pictures into the bugs, like so. So look for the little dotted blue box to come down. So there are 9 examples of bugs. Pop them all in. Drag, drag, drag. You could, of course, go on the internet and find pictures yourself and do the same thing. I just thought this would be easier for us to build our initial knowledge base of Pokemon bugs. I'll just pull that in again. And this one. There we are. So I can see here I've got my bugs all in here. I'm going to just stretch this window a bit so we can go back to a fuller screen. I'm going to leave my DigiLearn one just in the background here. So I'm going to show. So you can now see I've now got this new criteria called bug, and I've got examples of bugs in there. Now, once I've done that, I'm going to go back up here, click on back to project, and now we're going to press learn and test. This is the part of the system of machine learning for kids that's going to take all those buckets of pictures and try and learn some patterns between all the pictures that exist in each box. So I'm going to press learn and test. And it's told me the examples that I have here. We want to press the blue button that says train new machine learning model. This will take a few minutes to do so. You might get a little wait box that appears. There we go, training. There's a little quiz at the bottom. If you want to try the quiz while you're waiting, you're more than welcome. Which of these is not a good use of machine learning? You can figure out which one might be the right answer. I'm just going to train the model. So this is it trying to find the patterns in the pictures for each Pokemon type that we've put in. And once it's done, we are now then able to try and test our model. So it says you can test with webcam. So you can turn your webcam on and hold a picture. Perhaps you've got a Pokemon card and try it with that. You can test it by drawing something yourself, or you can put in the address of a picture on the internet to test what it's like. So if I go back to my DigiLearn Scott page, make this put it back here, you'll see underneath all the bugs, there's a section that says images, Pokemon testing images, and it tells me that Entei is a fire Pokemon. So what I want to do, I want to see if my system recognizes that Entei is a fire Pokemon. So I'm just going to right click on the picture. I'm going to copy the image link or the image address, whatever it says here. Click in here and then paste. So it pastes the address on the internet where the picture is, and press the button. And it's going to tell us it recognised Entei as a fire with 90, so it's 94% confident that Entei is a fire. Let's try another one. Let's try Delphox, who's here. Let's right click on Delphox. Let's copy the image link or the image address. Delete this one. And we'll paste in here. Test. It's 99% sure that Delphox is fire, and if that's correct, we've got Swampert. We can try this one too. Let's try Swampert. Right click, copy image link, and paste in here. Test. So I think Swampert is a water Pokemon and it's 73% confident. So you can go and test with all the different pictures that are here and give it a little go. What's interesting though is that sometimes it will get it wrong. And I'll give you an example. So in my system, if I copy Carbink, copy image link. So Carbink is a rock Pokemon. And yes, it says it recognises it's a rock and it's 64% confidence. That's pretty good. I'm feeling that my machine learning model is actually working quite well. But what if it was to classify it wrongly? I'm going to copy image link, try another one. Let's try the bug one that I've got. So 38% confident that this is a bug, which is true. Let's try one more. Let's try Kindra. Let's copy image link. So Kindra is a water Pokemon, but my system thinks Kindra is an electric one. You might get different results, but just now, that's maybe a problem. And I wonder why that's a problem. So when we go and have a look at this, if we go and see back up at the top here, and go back to my project, back to my training materials. So it said Kindra was an electric Pokemon. Let's go and have a look at electric and see what's happening there. Electric. There we go. So there's all my electric Pokemon. Now, why might my system think that Kingdra is an electric Pokemon? Any ideas? Well, perhaps the system has picked up the fact that there's this yellow part of Kingdra here. Perhaps these kind of little spiky horns are being picked up, like the shape. Because when you look at the electric Pokemon, they do all have spiky bits. And they certainly all have a bit of yellow in there. And there are some examples of electric Pokemon that do have a blue in there as well. So we'd have to maybe update our training data to say, well, let's maybe find some more examples of some water Pokemon and put them in. So if you wanted to, you could go off to a different website, perhaps find some more water Pokemon. Let's find some pictures. And we could add these pictures to our model. Let's find some single ones. Let's find one that's got some single Pokemon images. And perhaps you know the names of some Pokemon more than others. You'd find them specifically. There's one there. Let's have a look. You just copy that image. So I can copy image link. Might want to add that to my water area. So go to water, press the website link. I can just paste in the address of that picture. Grab that again. Copy image link. Paste, add. So I've added that picture to my water set now. So I can go back and I can add more examples of each of these different types of Pokemon to try and make my model more comprehensive. So you can give that a shot. Back to project. And once you've made any changes, you want to press learn and test again. Because I've updated it, I'll move this back across here so you can see what's going on. Train new machine learning model. Let's update it. Again, you can do the quiz while you wait if you so want. And that's it done. So I can now test again with some more pictures, but I'm going to just leave the testing bit just now and let's get on to the scratch bit. So once you're happy or happy enough that you've got enough of your Pokemon and it's given you pretty much what you expect the answers to be, you can go back to the project after you've trained it and press make and use Scratch 3, open in Scratch 3. And what this does, it opens a version of Scratch inside the Machine Learning for Kids website. And it has some pre-built projects which can help us to quickly get on with our task here. So the first thing we want to do is go to Project Templates and search for Pokemon. You're going to use the one that says Pokemon Images. And what this will do is it will give us a pre-built program that's got some pictures in there of some Pokemon, and it's got some little bits of code that's going to help kind of do the classification stuff. We could do a couple of little edits to this to connect it to our machine learning model. So what we'll do is if you look down the left-hand side of the Scratch interface, you should see the Machine Learning for Kids logo and the thing that says Pokemon Images. If you press that, you'll get this new list of commands here. And the command we want to look for is Recognize Image Label. So it's the first one. I'm going to pull this onto my stage on the Classify sprite. So make sure we're on Classify. Then take the variable that says Pokemon Image Data and put that into the recognize image command. I'll make that a bit bigger so you can see it. So what you're doing is you're taking recognize image label, Pokemon image data, popping that in there, and then we're going to take that full command and where it says set prediction to ... we're going to replace the ... with this. Now this will very simply connect our Scratch project to our machine learning model. Now to see this working, I'll make the screen a bit bigger. Press the green flag. And then if I take a Pokemon, drag onto the stage, this is Pikachu obviously, and we know that Pikachu is electric. When we press the button here, it will connect this picture to the machine learning model and try and figure out what type of Pokemon this is. So click. So it says it's Pikachu and it predicts that it is, we're waiting, electric. Yes, that seemed to work. Let's come back down. We have also Squirtle. Let's bring Squirtle up here. We know that Squirtle is a water Pokemon, so let's click on this and try that. That seems to work. Brilliant. This is Blaziken, I think this one's called, and I think Blaziken is a fire Pokemon. Ah, it seems to think that Blaziken is an electric Pokemon. Now again, why do you think that might be? Do you think there's a reason for that? I might argue that the kind of yellow spiky bits perhaps are quite electric-like as such. So maybe we might want to think about updating our model again around about what fire Pokemon and electric Pokemon look like. So I'm going to bring that back down and then exit full screen. So that's our simple Pokemon detecting tool. However, what we can also do is try and give our user some indication of how sure the Scratch program is, of how certain they are in terms of how certain they are that Pikachu is electric, how certain are they that Squirtle is water. And we can do that by using this command, recognize image confidence. So I'm going to just pull this in just now, make the screen a bit smaller. Recognize image confidence. And if I go to my variable, I can find my Pokemon image data and pop that in here. So remember that number, the kind of 99%, 37%, that's what that number is. So in order to use this in our program, we say recognize image data confidence, and we'll set that to a new variable so it appears on the screen. So we'll make a new variable called, let's call it how sure. Okay. And I'll take set how sure to the confidence level. And we'll just pop that underneath the prediction here, underneath the when I receive classify. So now when we have a look at our program again, I'm going to pop that variable over here. Let's have a look at the full screen. Green flag. So how sure are we that Pikachu is electric? 62.0223%. Okay. How sure are we that Blaziken was electric? 86, so it really thinks that Blaziken's sure that's electric, but that's wrong. So we're definitely going to fix our project model again. Let's try some other ones. 58% that Onyx is a rock. Seems okay. Right, so we can see there are some issues. And think about the data set, think about the pictures. What might we have to do to those pictures to make this a bit better? Let's think about the code for a second, though. 58.4355 out, it's not the most exciting number to read. We can use a function within Scratch, so back to our classify sprite. We can use a function within Scratch to make that number rounded. So if you go to operators, you have an option for one that says round. So towards the bottom, there's one that says round. So in operators, you can pull this in and say set recognize image, but let's round that. And let's pop that back in like so. So set prediction to the rounded number of recognized image, and that should give us a nicer number to look at. So let's try this again. Let's pull in Pikachu again. Click. Oh, I put it in the wrong. Oh, ha 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 ha. That was I meant to do that on purpose. I put it in the wrong thing, didn't I? Set prediction to be set how sure. Set how sure to round, not prediction. Terribly sorry. Let's try that again. Green flag. Pull the Pokemon. 62% sure, that's better. Onyx. 58% sure. Much better. That looks much nicer. Okay, so now we've done that, I'll leave the code here. So that's in the classify sprite. That's my classify sprite. We've got a working model. We could make it a bit better. So what if they were only 20% sure that something was right? Do we want it to be given a classification? Maybe not. So what I'm going to do is I'm going to add a couple of extra features to our program to make sure that it makes it a bit more user friendly. So to do that, I'm going to create a new sprite. I'm going to choose one. There's a little robot that I like. You can draw someone, but I'm going to choose a little robot to be my character. This one here, retro robot. I like that. There's my retro robot. I'm going to pop my retro robot up there, and I'm going to make the size, let's just make that 60% of the size. There we go. Here's my little robot helper. Now what my robot's going to do when the green flag clicks, when the green flag is clicked, I'm going to get to looks, get to say hello. So when the green flag is clicked, the robot's going to say hello. There we go. But when I do my thing like this, I would like my robot to tell me all of this stuff, all of the how sure it is, what its name is, what it predicts that it is, as opposed to having all these variables on the screen. So I'm going to show you how to do that. So back on my robot sprite, I'm going to say in events when I receive. I'm going to choose a new message. I'm going to call this feedback. So when I receive feedback, and we'll come to this in a second, what we want it to say is, I think that Pikachu is an electric Pokemon, and I'm 62% sure. That's what I want it to say. So in order to do that, I'm going to go to my looks and choose my say hello for a few seconds. I'll make that just 4 seconds and pop that in here. We're going to create a sentence that's going to speak our prediction back to us. So in order to do this, we need to use the join command, which is in the operators. So go to the green one that says operators and look for join. It says join apple banana. We can say, I think that, I'm going to put a space, take another join command and stick it in here. So I'm going to build a sentence by joining words together. So I think that, let's go to my variables, the name of the Pokemon you've said. So I think that Pikachu, take another join command, a bit smaller. I think that my Pikachu is take another join command. Let's find my prediction. So I think Pikachu is a electric Pokemon. So we need another join command. I think that Pikachu is an electric Pokemon. Oh, Pokemon. I am, to shrink this a little bit, I am another join command. I'm going to find my how sure variable. Percent sure. So now I've got this this saying that says join the words I think that, whatever name the Pokemon is a, whatever prediction it thinks it is, Pokemon, I am, what number, percent sure. So let's pop that into it says hello instead. So anytime the robot receives the feedback message, it's going to say that sentence. Now, when does it receive that message to do this? Well, if we go back to classify, after this, when I receive classify, we're setting those things, we're doing this, and then what we'll do is we'll call broadcast feedback. So recognize the image data, recognize the how confident it is, broadcast the feedback message. So that feedback message gets broadcast, goes down to the little robot down the bottom. The robot receives feedback and then says this sentence. So let's check that that works. So green flag. Let's pop in Squirtle. Click. I think that Squirtle is a water Pokemon. Let's try it again. I think Squirtle is a water Pokemon. I'm 91% sure. Hey, that's working pretty well. I think Lapras is a steel Pokemon. I'm 43% sure. So I think Lapras is actually a water Pokemon, but again, it's telling us that it's 43% sure. So I'm now making my program a bit more like an AI chatbot. Click this back. I can change a few things. I'm going to go back to the robot and just put some spaces after the A. So there's a space that appears there. That's fine. We can also then do things like we can add our own sprites to this. So just now I'm going to just pop these over here. I'm going to maybe hide my variables actually. Let's hide all my variables out the way. So it's just my robot that's there. But in here, all the different Pokemon, when you click on the Pokemon, you can see it's got the names of the Pokemon and all that type of stuff. There's one that says your Pokemon, and your Pokemon is blank. If you go in there and give your Pokemon a name, I go to costumes, and you draw a Pokemon. So I'm going to draw one very quickly with the tools. Or you could draw it with your paper and take a picture. Let's make that. Let's go for a water type Pokemon. So I'm going to make it blue. I'm going to add perhaps some eyes. C and V. And then another. So imagine that's my Pokemon, not the most exciting thing in the world. Delete that. There's my Pokemon that exists there. Make this size a bit smaller. Let's set it to like 40% the size, so it's there. There's my Pokemon down here. I'm going to give it a name. So the costume, instead of being called your Pokemon, it's going to be called, let's call it Star. This Pokemon's called Star. I should now try and figure out what type of Pokemon what my one is. So if I make this bigger, bring this back down here, put my Pokemon up, click. I think Star is a water Pokemon. I'm 96% sure. And that's because I think it's circular and blue. But again, if you draw your own Pokemon, give it a name, you could then try and guess what type of Pokemon that your character is. So our Pokemon predicting code is, there's not a lot of coding to do, but certainly we can make any adjustments we want to the Scratch program. So in the classify button, this is what we're looking to do. Back to that. So our classify button, move away, show prediction now. Wanted to say when I receive classify, hide the variable prediction, set prediction to recognize image, Pokemon image data, set how sure to the rounded value, so that finds that in the operators, to the rounded value of the Pokemon image confidence value. Then we're going to broadcast a message called feedback. That message is going to go to our new character